everyone. Today we are diving into the fascinating world of solar cells. Ever wonder how connecting solar panels in series affects their performance? Or what happens when you throw a variable resistance into the mix? Stick around because we are also going to unravel the mysteries behind the diode and its significance in this solar adventure.
Basically, what is solar cell? A solar cell, also known as a photovoltaic cell or a PV cell, is defined as an electrical device that converts light energy into electrical energy through the photovoltaic effect. A solar cell is basically a PN junction diode. Solar cells are a form of a photoelectric cell, defined as the device whose electrical characteristics such as current, voltage or resistance vary when exposed to the light. Working principle of a solar cell. When light reaches the PN junction, the light photons can easily enter in the junction through very thin pin-type layer. The light energy is in the form of photons, supplies sufficient energy to the junction to create a number of electron-hole pairs. The free electrons in the depletion region can quickly come to the N-type side of the junction. Similarly, the holes in the depletion can quickly come to the P-type side of the junction. Once the newly created free electrons come to the N-type side, cannot further across the junction because of a barrier potential. Similarly, the newly created holes once come to the P-type side cannot further across the junction because of a same barrier potential. As the concentration of electrons becomes higher in one side N-type side of a junction and concentration of holes becomes more in another side, that is P-type side of a junction, the PN junction will behave like a small battery cell. A voltage is set up which is known as a photovoltage. If we connect a small load across the junction, there will be a tiny current flowing through it. Let's understand the working principle of a solar panel in a unique way. Imagine each solar cell as a tiny power generator. When sunlight hits these cells, it gets them excited and they start producing electricity. Now, when we connect these cells in a series, it's like linking them up in a chain. This boosts the voltage. Think of it like adding up the power from each cell. Next up, the variable load resistor. This is like tweaking the gears of our solar setup. Adjusting the resistance helps us see how the system copes with different loads, simulating real world scenarios. And now the diode, the unsung hero. It plays referee, ensuring electricity flows in one direction only. Imagine it as a traffic cop directing the energy traffic. So, in a nutshell, solar panels are these incredible lights to energy converters. And today, we are uncovering the secrets of how they work. Stay tuned for some hands on experiments.
In this experiment, we use following apparatus like solar power lab trainer kit, then rheostat which having a value of 1K, then solar plates which convert solar energy into electrical energy, and for connection purpose connecting wires. First part of the experiment is when we applying variable resistor, how voltage and current of the circuit react. So firstly, keep the solar plate in sunlight so that it consumes solar energy. Let's connect the connecting probes to the kit so that variable resistor is in series with ammeter and in parallel with voltmeter. Let's see what effect on a voltage and a current of the circuit when we vary the resistance value. As we increase the value of resistance, the value of voltage will increase and current becomes 0. And when we decrease the value of resistance, the voltage will reduce and current going to be increased. second part of the experiment is significance of bypass diode. If one solar panel is shaded or dirt fall on it, solar panel acts as a open circuit. So circuit is gets disconnected and voltage across remaining diode might exceeds its maximum rating. So bypass diode is connected such that its reverse bias when panel is working. So when it is blocked, diode will become a forward bias and circuit will remain closed. Let's see it by experiment. We remove one solar plate or put it in shaded region so that it unable to conduct a current. In this case, current will reduce to 0, which is not ideal. Now we will connect bypass diode and let's see output in this case. Even we remove the solar plate, current will remain same because of bypass diode.
There are many perks to living a solar lifestyle. Using any of the following solar energy applications, you can create an efficient solar energy system right at home or an industry. First is the solar electricity, solar water heating, solar lighting, solar pumping, solar cooking, powering electronic devices using solar, solar furnaces, solar drying for agriculture.